Welcome, listeners, to another episode of Astronomy Daily with your host, Anna. Today, we have an exciting lineup of space-related news that I'm sure you'll find fascinating. From updates on NASA's lunar missions to crucial announcements about the future of the International Space Station, we have a lot to cover. Plus, we'll dive into some groundbreaking discoveries in planetary science, including the identification of a hot Jupiter progenitor. So, sit back, relax, and prepare to journey through the latest and most intriguing developments in the world of astronomy and space exploration. Let's get started. NASA has officially pulled the plug on the Viper lunar rover mission, which was aimed at exploring the moon's south polar region. Originally scheduled for a November launch, Viper, or the Volatiles Investigating Polar Exploration rover, was designed to search for ice and other resources in the moon's cold, shadowy craters. It was supposed to touch down on the lunar surface aboard the Griffin lander, developed by Astrobotic as part of NASA's Commercial Lunar Services program. The plan was for Viper to traverse about 20 kilometers over the course of 100 days, navigating in and out of permanently shadowed areas. So, what happened? During a press conference on July 17th, NASA announced the mission cancellation, citing persistent supply chain issues as one of the main culprits. Joel Hearns from NASA HQ highlighted the numerous delays in receiving key components, which consequently delayed the assembly, integration, and testing phases of the vehicle. Although negotiations had pushed the launch date to no earlier than November 2024, more delays loomed, pushing a potential 2025 landing, which would coincide with the lunar South Pole summer with more sunlight available. This ongoing cycle of delays risked affecting subsequent commercial missions as well. Cost overruns added another layer of complexity. Initially, the mission was budgeted at $433.5 million, with a 2023 launch in mind. With the push to 2024, the cost swelled to $505.5 million, and a 2025 launch would have raised the budget to a staggering $609.6 million. Out of this, about $450 million had already been spent. The rover itself is fully assembled, but the specter of future unknown costs, including more delays and potential fixes, made the project untenable within NASA's constrained budget environment. Interestingly, the termination of the Viper mission might not spell the end for the rover altogether. NASA is willing to open up the use of Viper and its scientific instruments to U.S. industry and international partners. Expressions of interest are due by August 1st, making it possible that Viper might still contribute to lunar exploration in some form. Meanwhile, the Griffin lander, initially set to carry Viper, will still proceed with carrying several private payloads and is slated for a moon mission in fall 2025. Other companies like Firefly Aerospace and Intuitive Machines are preparing for lunar launches later this year. This decision underlines the harsh realities and complexities involved in space missions, balancing scientific ambition with fiscal and logistical constraints. NASA has unveiled plans to deorbit the International Space Station using a vehicle developed by SpaceX. As the end of ISS's operational life approaches, this move is set to bring a controlled and safe conclusion to 2 decades of remarkable achievements and scientific breakthroughs conducted aboard the orbiting laboratory. The ISS, originally set to be replaced in the 2030 S, will not merely fall out of the sky. Instead, SpaceX's newly commissioned reentry vehicle will manage the entire deorbit process over a period of 12 to 18 months. This timeline begins when the ISS starts its descent from its typical orbit at 250 miles above Earth to roughly 136 miles, a safer distance for human-rated vehicles. SpaceX's deorbit vehicle, based on the Dragon spacecraft design, is an adaptation of the technology that has been ferrying cargo to the ISS since 2012 and crew since 2020. The key enhancements include robust trunk sections equipped with additional propellant tanks, specialized engines, and customized avionics. This pivotal role of SpaceX further solidifies its leadership in space operations, aided by its vertically integrated supply chain, which gives it a notable edge over competitors like Northrop Grumman. NASA disclosed that it has an agreement with SpaceX promising up to $843 million for the development of this vehicle, though this figure excludes launch costs. This mission will see the ISS drift downwards before the crew finally exits about 6 months prior to the final reentry. By that time, the ISS would have descended to about 136 miles above Earth, setting the stage for the final maneuvers to bring it down safely. Sarah Walker, director of Dragon Mission Management at SpaceX, expressed confidence in leveraging Dragon's rich flight history for this mission. The use of NASA-certified hardware for critical systems reduces risks and improves the likelihood of a successful deorbit operation. As the deorbit vehicle guides the ISS into Earth's atmosphere, the bulk of the station will burn up, with any remaining fragments expected to fall into a designated remote ocean location. This careful planning ensures minimal impact and adheres to international safety guidelines and practices. NASA's decision to use SpaceX for this nuanced and complex task was influenced by SpaceX's extensive experience and the reliability of its equipment. Beyond the technical aspects, this mission highlights an important transition in space exploration. The end of the ISS era paves the way for the next generation of commercial space stations and platforms. While fulfilling its role, the ISS has become an irreplaceable part of space history. As its operational life winds down, NASA and its partners are working meticulously to ensure a safe and dignified end. The ISS partners, including nations like Russia, which is committed to stay until at least 2028, will also have their parts to play in this concluding chapter. The goal remains to sustain constant progress in space experiments, while minimizing any disruptions up until the very final moments. In summary, this maneuver, facilitated by SpaceX's cutting-edge vehicle, marks a significant step in space exploration history. It showcases the intersection of advanced technology and meticulous planning, while honoring the legacy of a space station that has been a beacon of international cooperation and scientific discovery for more than 2 decades. Moving forward, the lessons learned and the technological advances made during the ISS's tenure will undeniably shape the future of human space exploration. Hot Jupiters are undoubtedly some of the most intriguing and extreme planets we've discovered in our galaxy. These planets, roughly as massive as Jupiter, have blistering orbits that bring them remarkably close to their host stars, completing their trips in just a few days. However, one long-standing mystery has puzzled scientists. Were these hot Jupiters always broiling on the cosmic stove? Or did they start off much cooler? Astronomers at MIT, Penn State University, and various other institutions have pinpointed a hot Jupiter in the making, effectively catching a planet in the act of becoming one of these incredible celestial objects. The findings, published in Nature, signal a significant leap in our understanding of how these enigmatic planets evolve. So, who are the key players in this discovery? Co-authors of this groundbreaking research include MIT undergraduate Hatem Im and lead author Arvind Gupta, along with a host of collaborators from numerous universities, institutions, and observatories. Their collective efforts unearthed a new planet known as TIC 241249530b, situated about 1,100 light-years from Earth. This planet boasts the most eccentric orbit ever recorded, and it's uniquely positioned to answer many questions about hot Jupiters. To visualize this, let's picture the planet's journey. TIC 241249530b swings extremely close to its star, then dramatically flings itself far out into space before reversing course and repeating the cycle in a narrow, elliptical orbit. If you mapped this orbit within our solar system, the planet would dive 10 times closer to the Sun than Mercury before hurtling past Earth and looping back around. But what is truly unique about this planet isn't just its eccentric orbit, it's also its retrograde motion. Unlike the planets in our solar system, which orbit in the same direction as the Sun's rotation, TIC 241249530b orbits against the rotation of its star. This setup provides a valuable snapshot of high eccentricity migration, a process where a planet's orbit wobbles and tightens over time due to gravitational interactions. In the case of TIC 241249530b, it orbits a primary star that circles a secondary star, forming a binary system. The gravitational dance between these two stars is causing TIC 241249530b to spiral closer to its primary star. As the orbit shrinks and becomes more circular over astronomically long periods, around 1 billion years, the planet will transform into a hot Jupiter, whirling around its star every few days. This evolution is far from a smooth ride. Milholland, an assistant professor of physics at MIT, describes it as radical seasons. The planet endures dramatic changes in starlight, scorching its atmosphere each time it nears its star. It's an orbital evolution so extreme that it almost reads like science fiction. NASA's Transiting Exoplanet Survey satellite, TESS, initially detected TIC 241249530b on January 12, 2020. Arvind Gupta's team at Penn State corroborated this finding with other observatories, confirming both the planet's size and its highly eccentric orbit through radial velocity measurements. These measurements revealed the gravitational tug that this giant planet exerts on its star, lending further insight into its unusual trajectory. Simulations of orbital dynamics played a crucial role in understanding TIC 241249530b's past and future. By running these models, Middled and Im could trace the planet's evolution from a cold Jupiter, initially far from its star, toward its destiny as a hot Jupiter. These models suggest that the planet's highly elliptical and retrograde orbit results from gravitational forces within the binary star system. This finding supports the theory that high eccentricity migration accounts for the formation of many hot Jupiters. Milholland eloquently summed this up by saying, "This system highlights how incredibly diverse exoplanets can be. They are mysterious other worlds that can have wild orbits that tell a story of how they got that way and where they're going." So what does this mean for our understanding of planetary evolution? This study not only sheds light on the life cycle of hot Jupiters, but also underscores the importance of multi-institutional collaboration and cutting-edge simulations in uncovering the mysteries of our universe. And as TIC 241249530b continues its perilous dance, it offers us a window into the complex and dynamic processes that shape planetary systems. NASA is now considering preserving small artifacts from the International Space Station, marking a reversal of their previous stance that no ISS components would be saved. 2 years ago, the agency had declared no plans to save artifacts from the orbiting lab. However, the tides are changing, and NASA officials are pondering what small parts of the ISS could be preserved as mementos. During a recent media briefing, Ken Bowersox, NASA's Associate Administrator for Space Operations and a former ISS commander, spoke about the station's immense impact over its 25-year history. He emphasized that the ISS has become a significant part of human spaceflight, accounting for almost half of the 60 years we've spent in space. For many, the ISS symbolizes international cooperation, groundbreaking scientific experiments, advancements in human research, complex assembly in space, and valuable insights into the effects of microgravity on the human body. NASA initially considered raising the ISS into a higher orbit, where it could wait without a crew until a future intact preservation effort became feasible. However, the propellant requirements were deemed too high, and the risk of debris impacts could potentially leave the remaining structure in pieces. Hence, they opted for a controlled reentry, utilizing a SpaceX Dragon-derived U.S. deorbit vehicle equipped with 46 engines. Interestingly, while large modules or truss segments won't make it back to Earth, smaller and more symbolic items might. NASA's revised plan now includes consultations with the Smithsonian National Air and Space Museum, as well as other organizations to develop a preservation strategy. Items considered for preservation include the ship's bell, ship's logs, display panels adorned with patches, and other meaningful mementos. NASA currently does not intend to allocate any dedicated missions solely for returning hardware, but expects that towards the ISS's end of life, there could be enough flexibility to return certain items. This will happen as the need to service or refurbish the equipment diminishes. Dana Weigel, NASA's ISS program manager, mentioned that returning memorabilia would be feasible as the mission requirements shift from operational needs to historical preservation. Other U.S. operating segment partners, like the European Space Agency, the Japan Aerospace Exploration Agency, and the Canadian Space Agency, also have their respective allocations for upmass and return mass. These agencies may decide independently what artifacts they wish to preserve. Unfortunately, similar arrangements do not exist with Roscosmos, Russia's space agency, as part of the ISS program's international barter setup. Ultimately, deciding which artifacts to prioritize for preservation will involve significant collaboration and negotiation among all partners. There's a potential for tension between scientific priorities and the desire to save poignant relics of the ISS's storied history. But NASA is confident that a fair and effective process will emerge. So, as the ISS nears the end of its operational life, prepare to see some of its pieces immortalized in museums, serving as enduring reminders of humanity's continuous quest to explore the cosmos. Thank you for tuning in to Astronomy Daily with Anna. I hope you enjoyed today's episode and found our cosmic updates as fascinating as we did. Remember, the universe is constantly evolving, and there's always something new to discover. If you want to stay in the loop with all the latest space and astronomy news, head on over to our website at astronomydaily.io. There, you can sign up for our free daily newsletter and keep up with our constantly updating newsfeed. Plus, you can listen to all our previous episodes to ensure you never miss a moment of the enthralling space-time continuum. And let's stay connected. Follow us on social media. Just search for Astro Daily Pod on Facebook, X, YouTube, and TikTok to join our community of stargazers, astrophysicists, and space enthusiasts. Once again, thank you for joining me on this journey through the cosmos. Until next time, keep looking up.